Hello everyone. So now we'll start with the session. A very good evening to all of you. Welcome to the first Android Study Jam of DSC TSEC. I hope that all of you are excited for the Study Jam sessions, wherein you'll be having lots of learning along with fun. To give you all a little context, as in why are we conducting these sessions, study jams are basically community organized study groups for people to learn any specific technology of any domain via an online training course. The reason why we are specifically focusing on Android, that is this particular domain, is the Google Developer Relations team, which manages the developer student clubs. They have a fixed plan in mind as to which technology do they want us to conduct events on for any month. Like for example, for the month of November and December, we had the Google Cloud events. That was the 30 days of Google Cloud program. And now for the month of January, we have been told to conduct events on Android development. And in future, we'll be conducting machine learning boot camps, web development boot camps, etc. So yeah, that was basically the reason. So now we'll be starting with actual session. So let me introduce all of you to our speaker for today. He's a student of our college, Karthik Soneji. He's a second year IT student. He is quite experienced in development, be it web, mobile, or desktop app development. He has been programming since he was in the ninth grade. He has been interning at Geminate Systems, and the most exciting thing is he has been a contributor to GSOC with MariaDB Foundation, and he has a lot of knowledge to share with all of us. So, without any further ado, I would like to hand it over to Karthik. So, Karthik, over to you.
Thanks, Monica. Thanks for such a wonderful introduction. So, hello everyone. Good evening. I will be taking this session on the basics of Android Studio. Today we'll be going over the setup and the environment setup and command line setup. So, if for those who have already set this up on your own, if you already have a working install of Android Studio, it won't be as helpful. I would still encourage you to sit around. Maybe you will find something that you might have missed in the original setup. But otherwise, we will have two more sessions after this that get progressively more advanced. Tomorrow we'll be building the first app, and day after we'll be actually modifying. We'll be writing some code to modify the app to make it do what we want it to do. So please feel free to check out the other sessions as well. But for today, welcome and let us begin. So as you can see, I already have Android Studio installed. I wanted to show the setup process, but it would take it takes around 45 minutes to an hour. So that I had to do it before. So if you, for those of you who do not have anything installed, if you are joining for the first time, if you're getting into Android development for the first time, then I will go over the steps to download Android Studio, the correct version for your platform. So the first step obviously is go to Google, type in Android Studio, and click the first link, download Android Studio. It is very clear. It should automatically detect your platform. For example, here it detects that I'm on a Windows 64-bit machine, so it will suggest the correct download. In case for whatever reason that is not working, you also have download options. It will give you all the available packages with the platform, 32-bit, 64-bit. The zip files. If you want a portable install, if you do not want to run, if you want to run it on an external hard drive or a pen drive or cannot run installers for whatever reason, then you would use the portable version. But for most users, the exe version is fine. For macOS, you have DMG files. Linux is star gz, which is a very, very popular format, a common format. But again, for most people, it is enough to go to this website, click on download Android Studio, accept the terms and conditions without reading as usual, and click on download. You can save the file. It'll automatically be saved in your downloads. I've downloaded this before, so I won't do it right now. So once you download the file, once you download Android Studio, just double click the installer, follow the setup instructions, and it should take you right to the screen, um, which I have opened right now. So this should be what you see when you open up Android Studio for the first time. Um, then the very first thing you should do when you when you install Android Studio is go to plugins, go to configure, go to plugins, and the Scotland plugin, it might be out of date. It might there might be a newer version released since the download. So update that first and click OK. Then you are ready to go. You are ready to begin. Um, so before I start with the Android Studio setup process, I would like to give all of you an introduction to Android, introduction to Android Studio, and about Android development as well. So Android, as many of you are aware, is a modified version of Linux. It is a heavily modified version of Linux, but it is still Linux all the same. So at the end of the day, you can it is a Linux install. It is an operating system just like Windows or Mac OS. It is a very heavily modified version of Linux that is built to run on phones. It uses the Java runtime environment JRE to run apps. So apps are built using Java, and they have a lot of APIs to facilitate that. But since it is Linux, you can also run native code. You can run C and C++ code directly on your phones without any modifications. And for that, there is something called an NDK. NDK stands for Native Development Kit. We won't be getting into native development and the NDK in during these sessions, but this is if you're interested, it is a good thing to check out. The VLC project, the VLC for Android project, makes heavy use of the NDK. So if anyone is interested, you are welcome to look at that. But the NDK is usually used for games. It is very prominent in game development because games need to be performant, and you cannot get the same level of performance with Java or Kotlin as you can get with C and C++. And also there are a lot of libraries for C and C++ that you can use directly without having to transcompile or have alternative implementation in another language. So that is the basic use case of NDK. Again, we won't be going into detail in this session, but these are just some things that I would like to go over before we begin. Now, once you install Android Studio, you will by default it'll install the latest SDK version, which is Android R in this case, API level 30, revision 3. So by default, this will be installed. It will install it only for you, only for your particular user. So you can see the location of the SDK is this path right here. Now it will also install some tools. It will install SDK. If you are interested in working with the NDK, you can check this box. It'll and click OK, which will install the NDK for you. It is quite a large download, so it will take some time. But if you are interested, you can download the NDK, and then the Intel emulator. If you're on an Intel machine, it will automatically install the acceleration emulator acceleration. We'll get into the Android emulator later on today. And finally, SDK update sites, you don't need to worry about this too much. This is just the repositories that the system uses to check for updates. So, so you noticed, I'll show you again, this SDK, Android SDK location. This is known as Android Home. So all the development tools, all the development, maybe NDK, SDK, CMake, whatever you download for Android will be placed in this location. And if you want to use them in the command line, if you want to have access to these tools in the command line, you will have to do some additional setup. Now, command line access is not required. It is you can definitely perform all the actions via the CLI that you could with the CLI with the GUI. It is just that the command line is easier to automate. It's easier to integrate into scripts, and sometimes it is faster than the GUI. So that is why if you are interested in using the command line, you will have to go through some additional setup, which I will go over right now. So remember this path. I will copy this path. I'll go to SDK manager. I will say edit. I do not want to edit. I just want to copy. But I will copy this path, and then I will have to open my environment variables. So in Windows, your settings will differ for each platform, but I assume most of you are on Windows, so that is why I will go over the steps for Windows. So let me share my entire screen. I will go over the setup process. So let me see. Yes. So to access the environment variables in Windows, you simply have to type env in the search bar. It will automatically bring up this tooltip, edit the system environment variables. You click that. It will show you the system properties window. Then you have to click this option right here, environment variables. And this will allow you to edit the environment variables for your user and for the system. For system, you need admin access. You need to be an administrator to edit system variables, but you can edit your user variables without admin access. So you will see that I have already set this before, but let us say that this was not present. If the entry was not present, you create a new entry, name it Android underscore home, Android home, and the value will be the value you just copied from here. So this value, the Android SDK location, that is your Android home, and you click OK, and this will set the Android home variable, environment variable. Now, one more thing you need to do is go to path. You need to edit the path. The path is to, it informs your operating system. It informs your command line, your shell, which folders contain executable files, which folders contain executable commands that can be run. So right now, if I try to run ADB, if I try to run any of the command line tools directly, it will the CMD, my command prompt, will not be able to find the files. So and that is why you need to add them to the path. To do that, you click on new to add a new entry. You type in Android home. But since this is a variable, this is not actual, and there is no folder called Android home. This is a variable. On Windows, you need to enclose this in percentage. Percentage denotes that you are dereferencing a variable. Then you will put a backslash to tell it that this is a folder. We need to go into the subfolder, and then type in uh, platform and dash uh, tools. So platform tools is the name of the folder in Android home in the SDK location, where it contains ADB, it contains some ADBD, which is the debug daemon. It contains command line tools that you would like to use when you if you want to access, if you want to gain command line access to your Android phone. So a lot of you will be familiar with this if you have ever routed your phone or maybe connected it to ADB. But otherwise, this is how you set this. You press OK, you press OK, and press OK, and that is that. Now, for you will have to restart all windows. You'll have to restart, close, and start all command prompt windows. For example, this is an existing window, and if I try to access ADB here, it will not work because this was open before the modification. So I'll need to exit out and start a new window, start a new command prompt, and then I will have access to all the, for example, if I type in echo Android Android home, it will echo out this value which we set, which we copied from here. You can verify it as the same, which means it is working. If I try to run ADB help, you will see that ADB help is working and it shows me the help text. So this is how you verify that you have properly set up the system, the platform tools, you have added to the path if you want to work with the Android device from the command line. Now, this is again not necessary, it is optional, but I would highly recommend that if you want to get into Android development, you do this. You learn to get comfortable with the command line because, as I said, Android is just a modified version of Linux. So you will need the more understanding of the command line you have, the better you will be able to work with Android. So then I did show you the SDK manager. So SDK manager is this thing. This is called Android SDK. That is the SDK manager. From here, if you need to target older versions, when I say target, if you need your app to build on older versions, you want to test your app to check if it works on prior versions of Android, then you will need to install these emulators. So usually, I think Android 7, 7, and 7 to 11 is one bucket. So most of the features from 7 to 11 are quite similar. So and then 6 and below are quite similar. So if you want to have the widest possible coverage, you will. I would suggest testing your app on the latest build of Android and also on Android 6. So and Marshmallow. Both of them, if your app runs smoothly on both these builds, then it should work on the majority of devices out there. For now, for simplicity's sake, let us just test to the latest version. I will not make any modifications. Then, okay. Then the next thing I would like to show you is the Android virtual device. So there's another option in this in the configuration menu called AVD Manager. AVD stands for Android Virtual Device. So one of the benefits of working with Android is that since Linux is open source, you can emulate it on various platforms on without actually having a physical device. So maybe you want to test on tablets, you want to test on smartwatches, you want to test on car systems, TVs, Android TVs, on smartphones. So instead of having to test on the actual physical device, you can emulate these devices on your PC, on your development machine, and without having to physically get these devices, you can run your app on these devices to see how it behaves. So when you install your Android Studio build, by default, it will create an Android virtual device for you. Not this exact one, but it will be very similar to this. You can see some information. This is the resolution. This is the DPI. DPI stands for sorry, DPI stands for dots per inch. It is the density of the display. This is the API level. API level.
Karthik,
Yes.
are you showing something other than the Android Studio
Oh,
screen?
yes. I think that is not visible. Let me
Yeah,
see.
we can't see anything other than the Android Studio screen.
Okay. So yes. So
Yeah, now we can see it.
yes. So this is called the Android Virtual Device Manager, AVD Manager. As I was saying, this is the reason you would want to use a virtual device as opposed to a real device is because you can change the resolution, you can change the form factor, you can change whether it is a smartphone, tablet, or watch without actually having to get to those physical devices. That is why it is beneficial. Also, you can be very sure that the state does not change between runs. So, for example, if you are running this device today, it'll boot up into the same version of Android, same exact environment as it would 1 week or 2 weeks or 1 month later. Your phone might be updated. It might receive software update, might receive security updates, which might change the behavior, but the Android emulator will not. So you can be sure that your app is consistent. So we can see some device details here. So this is the type. This icon signifies the smartphone, that is a smartphone, tablet, as opposed to a watch or a TV, an Android TV. This is the name of the emulator. For example, this is Pixel 2, which means it's a Pixel 2 device. Android 30. Android 30 is the API version. You can see that right here. Play Store. Play Store means it has Play Store enabled. I'll get into that in a bit. And x86 is the platform. So you have x86 and x64, x86. These are just different emulation platforms. x86 is better for performance. It is lower performance. So if you are say testing games, or it is not advisable to use x86, you won't be able to get good amount of performance. If you're testing normal apps, maybe a camera app, or maybe a simple bookkeeping app, then x86 is fine. You don't need the performance, and your OS, the actual OS, apart from the emulator, will run smoothly. Now, Play Store. The Android virtual devices. They are like unlicensed versions of Android. So what do I mean by unlicensed? Every Android version, every Android smartphone maker must have an agreement with Google to be able to include the Play Store binaries and the Play Store SDK support system on the with the phone. So, for example, a lot of you might remember Huawei, the Chinese smartphone manufacturer. They had some issues with Google because of the trade ban with China, and they had to stop shipping devices that had the Play Store code. Now, Android is open source. The full form of Android is actually Android Open Source Project (AOSP), but the Play Store code, the Google framework, Google applications, they run on a separate framework, which is not open source. That is proprietary. It is the license is owned by Google, and to be able to use that license, you need to have an agreement. So for testing purposes, Google does allow have some device, some emulator images that come pre-installed with Play Store. Some of them do not. The Play Store ones are few. They are limited in some, like the version numbers, but they allow access to a more realistic scenario of how your app runs. If your app does not depend on Google services, then this does not matter as much. But if you're using Firebase, or if you're using something like Firebase push notifications, then having Play Store enabled will make your development more accurate. The Your emulator will be more accurate to the device that it runs on. And this is the resolution, as I was saying before. This is 1080 by 1920, 420 DPI. API level is 30, which is the latest. Target is Android 11, Google Play. CPU, as mentioned, as we discussed, this is x86, which is faster. It compromises on performance of the emulator, but it allows your OS to run faster. And size on disk 13 GB. When you create a brand new emulator, I'll do that right now. I'll walk you through the process, but you will notice that the size is very small. This is because it is just a system image. When you boot it for the first time, it will take a lot longer because it has to unpack the system image and create all the supporting file structure. So right now, you can see this arrow. You have some options like duplicate, wipe data, cold boot, show on disk. So duplicate is self-explanatory. You can duplicate this emulator if you want to make some changes, but still keep the original. Wipe data is if you have data, it is like a factory reset. So if you're using an emulator for a long time, you might have some data that you do not want while testing. You want to start from a clean slate. You want your app to you want to see how your app behaves when it is installed for the first time. So then you might want to wipe data. Cold boot. So this emulator has a feature that is known as hot start, hot boot, wherein it will save the state. So when you first start the emulator, it will perform all the actions. It will uh, go through the entire startup process. But once the emulator is running and you stop it, it will save the state of the emulator. So if maybe you have three apps open and maybe you have music playing in the background, if you save the state of the emulator and shut it down, it is like turning off your phone. It's like suspending your phone, like pressing the power button once. The phone itself is not on. The phone itself is not on, but whenever you start it next, you do not lose the state. The music will still be playing, the apps will still be open, and you can resume from where you left off. So cold boot, if for whatever reason your hot boot, your save state has corrupted, or you do not want to load the save state, then you can cold boot, which will bypass that state loading. Sometimes cold boot is faster, but usually once the cold boot is faster, but the setup has to happen again. So that is why overall it takes longer. So usually you would use hot boot. Very rarely, if you're facing issues, if maybe your emulator is crashing or something, you would try to use cold boot. Show on disk will show you the physical location of the files of the AVD. So it will show you where the data is stored on your file system. View details is for, it will show you the debug details. It will show you all the information. So if you have found a bug, if you want to replicate the exact state, you want to check if the state is the same between two emulators, you can use this details. And then finally you have delete. Since it's Unity, you can delete this emulator if you want. Now, if you click on edit, if you now by default when you install Android Studio, it will already create one emulator for you. It will create one, like, uh, emulator by default, and you can delete that if you want. I would suggest simply going to the options and editing. So this is the name. You can change the name, obviously. It'll show you the pixel. It'll show you the device configuration, which is pixel in this case. um, and this is the screen size. This is 5 inches, 5 inches diagonal, and this is the resolution, XX HDPI. So there are standard resolutions. The Android defines some standard resolutions: SD, HD, XDPI, XXDPI. So this is XXDPI and Android R. So startup orientation. This is just the default orientation of emulator. So usually it is portrait. Again, if you're developing an app that needs to be used in landscape, maybe a video player, you would prefer it to start in landscape. Then you have advanced settings. In advanced settings, you have camera. You can have a front camera, back camera. You can have network. You can throttle the network. So maybe you have a very, very fast internet connection, which is good, but maybe you want to test how your app behaves on a slower network. Maybe you want to see what happens when it loses network connectivity for whatever reason. Maybe you are in an airplane, so you can check. You can throttle your network to these speeds. These are again predefined speeds. So LTE, Edge, GPRS, GSM, and latency. Latency is again how long the network requests take. Um, then emulated performance, again, as I mentioned, we have cold boot, quick boot, and snapshots. Now, snapshots are the like, you can save the state to a disk, so that way you can, as I was saying, you can have music in the background. You can have three apps open, and quick boot will resume that state. Now you can choose to save that as a, like, checkpoint and go from there. So maybe you have 3 or 4 setup steps. You have to sign into your app, you have to configure some options, and then begin testing. Then you can choose, you can save that state to a snapshot, and every single time you boot your AVD, every single time you start your virtual device, it will resume from that snapshot. So you do not have to go through the setup process again and again. Right. So imagine something like Spotify or Netflix, where you have to you have to sign into an account, and then you can begin testing. So this is useful there. Now, memory storage, again, internal storage, SD card. So the difference between internal storage and SD card. Now, later versions of Android, there isn't. They have blurred the lines, because you can configure your SD card to extend the internal storage. But for prior versions, SD card would be like offload storage. It would be where you offload your data, app data, whereas internal storage is where you keep the most core files, like only the important files. So you can change those sizes if you wish. Now, um, device frame is the black colored. When we start the emulator, I'll do that right now. It is the black colored border around the emulator. So again, that is just so that you get an idea of what it looks like on a real device, with the borders and all. You can disable this if you prefer. The I like to keep this disabled by development, because I find it adds a lot of clutter. But once, when you're taking screenshots and maybe when you are doing final tests, I would recommend enabling it, so that, just so if there's a notch on the device, if there is a hole punch display, just to ensure that nothing important is being cut off. Yes. And then finally, keyboard input, and you can say finish. I don't want to modify anything, so I'll say cancel. Now, when you create a virtual device, you will see this menu. There'll be a lot of options, so we'll go through them one by one. Now, this is the name of the device. You'll recognize a lot of these names very very popular devices. Pixel series is Google's own line of phones, so that is why they are mentioned very prominently. You'll also find some old phones, like very old phones, like Galaxy Nexus is again. This is the Nexus line was the older Google line, Google branded line of phones. Then you have these generic devices. So this is a newer, a very recent one, the 8-inch foldable, 7.3 foldable, 7.3-inch foldable, inspired by Samsung and I think again Huawei's recent advances in foldable phones. Like this allows you to get a head start, develop your. Even though foldable phones are not very common right now, if they do end up catching on, then you can get a head start to develop your app for these phones. Again, an emulator is very useful here because it allows you to develop these. Develop for these platforms without actually having access to the platform, the hardware physical access to the platform. Then yes, then we are coming to these generic devices. These generic devices are for all other phones, all other kinds of phones. So maybe you have Oppo or Vivo or Samsung. Because there are so many different manufacturers, it is easier to simply define them by device size, which is the double quotes mean inch. So this is a 4-inch diagonal device, and the resolution. If you need more specific information, it is available here. And you can also create a brand new hardware profile. Now, hardware profiles are little involved. We won't go into detail right now. But if you are targeting a very specific device, or if you're having issues on a specific screen size or density, then you can create a special hardware profile to see what is the issue with those. Maybe it is because of a special resolution or something. Uh, so you can debug that. Um, then here you can see category. So as I mentioned before, nowadays you have Android smart TVs, you have smartphones, you have Wear OS, which is for watches, you have tablets, and automotive. Automotive is Android Auto, which is again, all of these are modified versions of Android. For example, Android TV and Android Auto are they are a custom launcher on top of the default Android system to allow it to work in that setting. So TV, for example, you have two options as of now. 55, both are 55-inch, just a resolution change, and you can maybe emulate a TV in this case. Wear OS, you can emulate these watches, Android watches. Now you will notice that around chin. Now a lot of devices in to get a better screen to body ratio, they will have chins or they will have notches. They'll have whole bunch displays. And as a developer, it is your job to ensure that these displays, that your apps run properly. Nothing important is cut off on these displays. So these are a good way to check. So this is a category of the most popular uh, sizes of the configurations out there. But again, if you are targeting a specific configuration, if you are having a specific product you have in mind, then you can create a new hardware profile with all of these settings. You can customize the shape, the density, the pixel density, the resolution, everything. And tablet, again, these are Pixel C, Google's tablets. You have Freeform, which is again a generic device, and automotive is the dash. So automotive and tablet are not very different in the dimensions. Both of them, if anyone has seen like photos of a Tesla, it is like a dash, a central console with a large tablet attached to the car. There is not much difference in the physical form factor, but the actual device system, the operating system is very different. So the tablet and automotive emulators, they only differ in the base system image. So once, for example, let me create a new Pixel 4 definition. So you will notice that no other Android system has Play Store enabled except phone, and even in phone, only a few of them have this Play Store symbol here, this icon here. This means that only these like Pixel 4, Pixel 3a, only these devices, only these system images can run You can access the Google Play Store. You can access the GS services utility functions. They only will have access on these devices, not on these devices. So let us say I want to create a Pixel 4a. I'll go through the steps right now. So I'll select the device from here. I'll click on next. Then it'll ask me to choose a system image. So you can choose R, you can choose Q, Pi, as I said, whichever one you feel is better. You want to develop for them. Uh, the x86 images, as I mentioned, they are slightly this. This is the other version, x86 underscore 64. The other option is x86. x86 64 is slightly more performance intensive. It needs more system resources, but it runs faster. So if you need that, you can choose that. Right now, I'll just go with the default. Click on next. It'll ask me to name the device, so I can change the name here. I can change the startup orientation, the settings, everything that we went over before. You will notice that some of the settings can only be configured um, during the creation. For example, I can only specify the size. I can only change the size during creation. Once I create the AVD, I cannot extend the SD card. So 512 MB is usually good. It is more than enough. If you need more, maybe you are working on a device, an application that downloads large amount of data, you can increase the file size here and then click on finish. Right now it will this will take some time to finish to create the Android virtual device, and you will see that it appears right here in the list, and I can start this. As I mentioned, when you create a device, this the size on disk is very small. When you start it for the first time, it will take a very long time to start because it has to pull in a lot of system definitions. It has to create the first file structure on boot. So that is why it takes some time. So I will attempt to start the old one. This so right now we don't need this. This is just a demonstration. So I'll delete this right now, and I'll try to start this. Now AVDs, they are very um, they are notorious for having needing a lot of memory. They have a high amount of memory consumption. So I'll attempt to start one right now. It may be that because I'm sharing my screen, because the screen capture is running right now, I may not be able to start this. If that is the case, then we already have a backup. So we might need to use that. Let me share the screen. So this is what you should only see a black. Wait, maybe I'll share the entire screen. That is more. Um, yes. So this is the how the emulator looks when it starts. Right now it is black because it is just starting up. Emulators take some time to start because again you are emulating an entire virtual phone on your system. So they consume quite a lot of memory. I would suggest turning it off when you are not using it, when it is not in use. Um, so we'll give it maybe 2 minutes to start. In the meanwhile, if anyone has any questions, I'll be happy to answer them. So,
Karthik, do you want me to share the emulator, or are you fine?
so let us wait for. I'll take some questions if anyone has questions, and by that time, if it doesn't start, then we'll see what.
All right, sure.
So, does anyone want to ask something? No.
So I had one. I know I'm supposed to be the organizer, but I was just listening to you, and I asked this in the chat as well. But
Oh, sorry.
what is x86, x64, and x32 like? What is the relation between them?
Yes. So, um, x86 is for a lot of historical reasons I'll not get into right now. X86 is what is 32-bit. it sounds strange, but x86 is 32-bit and x64 is 64-bit. So x86 underscore x64 just means 32 and 64-bit. So it uses both 32-bit mode and a 64-bit mode to get the best performance.
Okay, so it's like the best of both worlds kind of thing.
No, no, no. So it is so Android again, because Android traditionally did not need a lot of memory, did not need a lot of computation power. Then most of them were ARM chips. Most of them were still are ARM based chips. Qualcomm, Snapdragon. Huawei has their own line of processors. I think Kirin processors. Um, and Samsung has Axios. All of these are ARM-based processors, which is different from x86 from Intel and AMD x86-based chipsets. Um, but Android again, because it is open source, people have added support for x86. So there's a project, a very nice project called Android x86. Maybe I'll go over and show you. So let me share this tab. Yes. So there's a very nice project called Android x86, which allows you to run Android as your primary operating system, like so Android x86. Um, it is like because again Android is a version of Linux. You can run it on your laptop, on your PC, like you would any other operating system. And here are some screenshots if someone is interested. um, and the benefit of having this kind of native support is that unlike iOS or unlike other microcontrollers, you can natively like emulation is very good. Support for emulation is very good. So having an x86 based um, image on an x86 based computer or or 64-bit computer is good, but having the support for an additional instruction set, 64-bit has a larger instruction set. So having that support will make it allow it to run faster at the expense of more resources. So
Oh, okay.
x64 is better in almost every way to sorry yes to x86. Like 64-bit is always better than 32-bit, but having both the instruction set, it allows it to run faster.
Oh, okay. Thank you. If
So
anyone else has any questions, please feel free to ask in the chat or by just unmuting. Karthik is pretty open for any kind of questions.
yes. So let us see. We'll wait for the emulator has started, but I'll still wait for maybe 1 or 2 minutes if anyone wants to ask something, and then we can move on to the last part, which is ADB and the command.
Sure. Have any of you all used Android before? Could you all just either unmute or type it in the chat? It would be nice to know how many people have used Android here.
Okay then. So if in the interest of time, if you have any questions, please interrupt me. But in the meanwhile, let us move on. So this is what the emulator looks like when it is fully booted. It is, as you would note, it is like a fully functional Android device. You can, see these toggles. You can see this Bluetooth, do not disturb, battery. Um, and as I mentioned before, since this is a Play Store build, it has like support for the Play Store. You have the Play Store. You will need to sign in. Now, signing in on an emulator is it. There are like if you check online, what is the best practice? You will have conflicting the answers. Some say that it is perfectly okay. Some say that it compromises security. Now that is a decision you have to make. If you have a dedicated developer account, maybe it is better to use that. If you are in an enterprise setting, if you have maybe Google for Enterprise, or if you have a managed GCP console, GCP subscription, then you will most certainly receive service accounts for this purpose. So you will find you will get service accounts to sign into Google Play separately. But I would suggest, just for to be able to keep devices separate and to ensure that you are not, accidentally leaking information, I would suggest you create a brand new, like, separate Google account for development alone, and then sign in via that. So that allows you to have more flexibility. So right now I won't sign in because security, and I just wanted to go over this. FX is not install apps directly through ADB, or you can go in and enable APK installation. You can enable installation of unknown sources. Now that is a very common method that I think a lot of us have used in the past. Like, all those with Android phones are familiar that you can go to settings, you can go to security, unless it has moved, go to security, and there is in newer version of Android there's a permission you can set, like app level permissions. You can allow installations from some apps instead of other apps, but in general you can, if you allow installation from unknown sources, you can install APK files directly, which is very useful for development. So yes, if you go to security. Okay, so maybe there are a lot of guides online you will find. Should not be very difficult. Now, this is another issue that you might run into. The emulator will throttle sometimes if the load is too much. It will kill apps to free up memory. Um, so I think now it is now an app level permission. But yes, you can search for it. So if I search for unknown. So by the way, Android has excellent support for keyboard and mouse. It is an accessibility feature, so um, the emulator already knows how to talk to a keyboard. It will not show up a virtual keyboard unless you force it to. You can force that if you want. So yes. Um, the next thing I would like to go over once is maybe the emulated menu on the side. So I don't think you can see the menu right now. I will have to share. Um, so the emulator, if you can see this device menu, if you can see these buttons on the right, the emulator has a lot of options. Like, this is the power button. This is,
We can't see anything.
sorry, you cannot see anything.
It is a just widescreen.
Okay. Hmm. Let me see. So now can you see something?
Yes.
Yes. Good. So as I was saying, so when you press the power button, it is just like turning off your phone, turning off the pressing the power button on your phone. It will suspend the phone. If you press it again, it will come back, just like a normal phone. You can rotate the device. You can rotate the configuration, which will make it landscape, or you can make it back to portrait. You can take us. This is to capture screenshots. This is for hardware buttons for devices that used to have hardware buttons. It is very rare right now, nowadays, but they're still available. Then there is this more menu which will open up more options. So you can set the location, you can set additional displays like secondary displays. You can change the battery. You can, I want to make it maybe 50%. I can change the you can see the battery level is changing as I move this bar. I can change the battery health, which is how many cycles. I can maybe show a dead battery. I can maybe show an unknown battery. The phone does not detect the battery. I can emulate a charging connection. I can say it is charging. You know, a charging indicator. I will have to set it to good, and maybe it is fully charged, right? And AC charger. You will see that the charging indicator has appeared right here. I can change the cellular network. I can say, maybe it is great signal strength. Um, and maybe it is 5G. You should see the 5G logo pop up on the bar. So these are like device state changes that you can edit. Fingerprint, you can register like up to 10 fingers and touch the sensor. Right now it doesn't do anything, but if you're developing, say for example, WhatsApp has a feature that will lock your apps, lock your chats using fingerprint. This is how you can test something like that. There are virtual sensors. Virtual sensors, you can change the orientation of the device more finely. So right now, I can rotate. I can say so for example, a lot of games like Temple Run. A lot of us have played Temple Run. That has motion control. So you have to tilt the device like this to change lanes, and this is again another way you might test that. You can also move the device. This is like an accelerometer reading. So like shaking the device. Again, Android has another feature. When if you shake the device, it can perform certain actions. This is how you would test that. This is Google Play. You can change the Google Play services version. You can update, downgrade. This is the snapshots I was referring to earlier. This is the if you want to maybe pre-configure a state, you can sign into the app, you can load a screen and then load the snapshot, so you pick up from where you left off. You don't have to go through that again. So this was the basics of the Android emulator. One last thing I would like to cover. It is almost 7, so I'll wind up quickly. um, the
Take your
so
time, Karthik. We're in no hurry. Take your time.
Yes. So the Android emulator, as I mentioned before, can be you can interact with it using the command line, and it again you can perform all these interactions using the GUI, but the command line is sometimes faster, sometimes more powerful. So the way to interact with your Android emulator is there's a command called ADB, which we checked previously using ADB help. ADB stands for Android Debug Bridge. Says it right here, Android Debug Bridge. And if you want to know more about the options, there is a very nice manual on Google that will tell you about all the options in detail. For right now, I will just show you some of the commands you can do. So ADB install can be used to install an app. So it will if you pass it the name of an APK file right here, it can install an app. It will install the app on whatever device is connected. To see which device is connected, you can run the command ADB devices, and you will see it will show emulator 5554, which is what this shows here. 5554 is the port on which the ADB service is running, and this is the emulator. And in the same way, you can also connect to an actual device. So you don't have to. You're not limited to testing your app on other devices on the emulator. You can also test on a physical device if you have one. So usually it is recommended that you first test your app on the emulator, and then later on, once you are sure that it works on the emulator, you can move on to device testing, because device testing is usually slower. Um, then you also have commands like ADB shell. Now, ADB shell is, as I mentioned before, this is just Android is a modified version of Linux. So ADB shell will give you actually a reverse shell. So this is called a reverse shell. because it opens a shell on the target of the emulator. So it will allow me to explore the file system. So standard Linux commands will work. Standard the like ls will show me all the files. I can cd. I can go to the root of the and the file structure, folder structure. I can maybe go to the SD card. I can go to SD card and show me the files there. This is a typical setup of the file structure in Android. Then you can also you also have access to some utilities. For example, grep for finding, for filtering output, for finding things. You have AM, which is Application Manager. It allows you to start apps, launch apps directly from the command line. So if I want to launch maybe messages or Chrome, I can do that directly. You also have find. If you want to find, if you are familiar with the traditional commands, Linux commands, find will enumerate a directory tree and other things. So SU is a very special command. For those aware, SU stands for super user. If you type this on a standard Linux install, like a normal Linux, it will prompt you to enter the root password, and it changes the user to root. It gives you root access, admin access. Now Android, since most Android phones, you do not need root access. It is very dangerous for security. It is not like it is difficult to control apps that have root access. So by default, most consumer Android phones will have root disabled. Also, all Google system images, all images with Play Store will also have root disabled. But other generic images, other generic Android images will have root enabled. So what this allows you to do is directly inspect your app data directly. So you will notice that this Android/data folder, if I try to go to this Android uh, data folder, it will not allow me to list anything. It will not allow me to see the files, see the folders, create a file, because this is privileged data. Each app has its own folders, and no app except that app can read those folders. So you cannot read the data from another app directly. So if you are root, unless you are root, so if you are root, you can inspect the data for if you have issues, for debugging, for testing. You can change the data. You can see what happens. As you can try to see if your app can recover from a corrupted state. You can see what happens if the some data is missing. So those kinds of things. So this is the Android shell. It is very, very powerful, especially once you get into more like app development where you need to test for testing. It's very useful to be able to navigate directly into the Android system and modify things. You can also copy, you can transfer data from the device to your PC, or from the PC to your emulator device using Android ADB push. Push is, if you look at the help text, you will notice that you have ADB push right here, file transfer, push, pull, and sync. So these are some of the most used, most commonly used command line options that you usually use while app development. Um, Yes. So other than that, I think that will be all for today. Thank you for listening to me for so long. So if anyone has anything they would like to, ask or add on or something, please, you are welcome. If not, then thank you again for having me. And we have two more sessions, as I mentioned. Um, One tomorrow. Tomorrow we will be going over cloning. We'll clone a standard project. We'll clone an example project from Google, build, run, and test it on the emulator. So if you're interested, please do join in for that. And a day after, that is the 24th, we will be modifying that project, modifying the example project to and writing some code. So again, if you're interested, please do join in for that. Otherwise, thank you. Thank you
Yeah.
for.
Everybody, just before leaving, please make sure to go to the chat section. We've posted the link for the for tomorrow's section. Please go and register for that.
Yes. So the session is over. So if you do not have any questions, if you do not have any comments, please feel free to share. Otherwise, you can leave.
Yeah. Once again, don't forget to register for tomorrow's session. Link is in the chat. Karthik, are you there?
Yes.